Hi guys, it's Ananya here. Winter break just started for me, so I wanted to hop on this little journey of mine. Basically, I'm really interested in getting to around 2,000 LeetCode problems this semester and upcoming year, and so I thought, why wait to start my New Year's resolution right now? Let's just do it pre-Christmas and hope that it sticks throughout the New Year. So I'm going to start with the first few LeetCode problems, and I am not a beginner when it comes to programming, but I'm definitely not the most advanced there is out there. Multiple people are much more talented than me, and that's part of the reason why I'm doing this, because I want to improve myself. But if I can explain any of these LeetCode problems well enough that it helps you understand it as well, that would be such a blessing and such an honor of mine to do. I'm just going down the list to start here, but basically you're given an integer, array, or vector of numbers and a target sum that you need to find two indices that are not the same that sum up to this target number. So problems get harder, I promise, but basically what I need to declare first is an answer vector that I can store my answers in. Next, the largest numbers dot size can be is 10 to the 4th, so I'm not too worried about any time complexity issues. If I is not equal to j and nums I plus nums j equals target, then just and because there's only one solution per input, we can just return yes. And generally I think it's also nicer to do it that way. Let's just do a sanity check. All three cases pass, and then alright. Okay, so this problem is called add two numbers. Seems like a simple task until you realize that the numbers are stored in reverse order in two separate linked lists, and what we need to do is return the sum of these numbers as a linked list. So basically the first question you're probably going to be asking yourself is, what is a linked list? And a linked list is essentially, you can think of it like a train car, where every single number is represented as its own little train car. And every train car has a value, and it has the train car that it's connected to. So there's two separate things in this train car, which we call a node in a linked list. There's a value, and then there's a next pointer. When you want to traverse this linked list, you keep track of your current pointer, which starts at the head, and while the current pointer is not equal to null, you just access the next train car. And, well, why do we use a linked list? Basically, the problem that a linked list solves that an array does not solve is the concept of dynamic memory allocation. So you can do constant time additions and deletions, which if you were to try to do that in a vector or an array, would take much more time depending on where the value that you want to add or delete is. Okay, so let's start solving this problem. Basically, the first thing I'm going to do is create a list node called the head, which, as I showed you before in the diagram, this is what usually starts off most linked lists. The catch here is that if we tried to push this head pointer along and iterate the entire linked list using this head node, we would actually lose track of exactly where we started. So for that reason, I'm going to create a list node called dummy, and I'm going to just set it equal to head for the time being. That way, when we finish creating this linked list, we can return head next. And for a little bit of a deeper explanation, basically if we return dummy dot next, dummy, when the program finishes, is probably going to be at the very start of one of these numbers. In this case, if you return dummy dot next, you will actually just be returning a null pointer because this is the end of the linked list, and the last train car, so to speak, actually just leads to a null pointer. So for that reason, we need to start at the head and return head.next. Actually, head starts before, and the next that we return starts at 2. So once I've created my dummy, which is equal to the head, I can use the dummy to traverse the array, the linked list. So I start off with while at least one of the two nodes, L1 or L2, has to exist. So while one of them is not equal to a null pointer, at least one of them, then I can, begin my logic. So we don't know which one is equal to null pointers, so what I'm going to do is I'm going to set two values, v1 and v2. If L1 is equal to the null pointer, then that means that we've reached the end of the first number, and what we need to do is we need to set v1 to 0. If it's not equal to a null pointer, so to speak, then let's say it's equal to 2. What we need to do is we need to get v1 to equal the value that is currently in that list node 1. And once we have set it equal to 2, what we can do is we can push the list node forward in the numbers. So L1 is equal to L1 dot next. Now, we can pretty much copy paste this logic for the second pointer. Just make sure we change everything correctly. All the 1s become 2s. Likewise, just to re-explain this really quickly, if the second list node is equal to a null pointer, that means we've finished all the digits that are in that second number. So we need to set v2 equal to 0. And if it's not equal to null pointer, that means that we can start up, it's one of these numbers that are in the second number. And what we need to do is we need to access the value in that digit and then push the list node forward. All right. Now, what we do here is we can implement some arithmetic logic. This should be pretty simple for most of you. Total, carry. Now, what we have so far is we have to calculate total, v1 plus v2 plus carry. Carry, how we normally do math, is going to be total divided by 10. And then what we do here is we do dummy.next is equal to create a new list node that we can add to construct our linked list, is equal to total mod 10. So it's the last digit of the entire number. And then we can do dummy equals dummy next. The one case that I need to consider here is if, let's say, the last two digits sum up to a number that is much greater than 10, meaning we need to construct an additional list node. If carry is greater than 0, that means we need to construct one more additional list node, and we can set dummy.next equals new list node of carry. Alright, and then at the very end, as we said, we can return head.next. Head started up here, so we would then be returning 7, 0, and 8. Alright, so I think this logic should be fine. Let's see if there's any errors. Just a quick sanity check here. Alright, all of these cases were accepted, so... Alright, perfect. So we ran within 4 milliseconds, so not too bad. Okay, so let's move on to problem 3. It's called longest substring without any repeating characters. It's pretty intuitive. It's kind of what the name suggests. When you're given a string S, you just need to find the longest substring without any repeating characters. They gave us 3 examples, ABC, A, B, C, B, B. It's going to have ABC as the longest substring, just one of the longest substrings. When they're all the same characters, you're just going to have the longest substring being 1, and then the third one is also just going to be WKE. When I look at the time complexity constraints here, I'm going to see 5 times 10 to the 4th. So if I were to write an O of n solution to this, the one that comes to mind fastest would be sliding window, which is usually O of n. Sliding window, the way it works is we basically have... Let me just use this as an example. So we have a left pointer and we have a right pointer. That's going to start off both at 0. We slowly inch the right pointer forward until we find a character that has already been found before. And in this case, because we did find the character within the sliding, like that little window that we've created from A to A, we just shift the left pointer forward a little bit and then keep going again until we find B. Now we can inch the left pointer forward again. We found C. Inch it forward again. And in this case, it's not that we found a character that is equal to the left pointer. It's that we found a character that has been found already once within the string, forcing us to have to end our sliding window position right here and choose C as the new left position. And then we just finish it off just like that. So let's start coding this. Basically what I need to do is I need to store the last position that we found all of these characters in. Okay, so let's use like a makeshift vector int answer, and we're gonna have 256 indices for 256 characters in the ASCII library. We're gonna set all of them to -1 because this is the array of last found position for each character in the string. Let's see. Okay, now we need to initialize a couple different variables. We need to initialize a left pointer, a right pointer. We call them pointers, but really they're just, you know, placeholders for iterators that we try to move around in a sort of window-esque fashion. And then we have the length that we can track by just doing right minus left plus 1. Okay, so let's implement the sliding window part. Usually it starts off with while right is less than s.length. What do we do here? The first thing we have to do is kind of intuitive. We need to push right. What about, do we do anything before that? Well, for every single one of these characters, we need to track. It's called answer, isn't it? It's called s of right. Whatever character we come across, we have to set that last found indice to right, wherever our rightmost pointer is. And then we also have to calculate the length. So let's do length equals max of whatever the current length is, vs left, right minus left plus 1. Okay, alright, now what about setting our if? So we have to set the left a little bit differently. We can't just auto set it. So there's two cases, okay? There's the case where, let's say here, in this case, let's say we're starting off our leftmost window at B. And if we're just tracking the lastmost position, like the last found position of all of these characters, we need to keep two different cases, don't we? The first of which is if we start off our left pointer at A, and we keep on going until we find that A has been found before within our sliding window. Then we just need to shift it to the next character from the last found position. So if found before within sliding window, what does it become? Left is going to equal the answer, like, oh, the last position of that specific character plus 1. So we'd start off at B then. If found before, but not inside sliding window, left just equals left. Alright. Is there a way to simplify these cases? Let me see. So if that answer s of right is not equal to -1, kind of takes care of both cases right here. Basically, left just has to shift to the one that's greater of the two, right? Yeah, because in that case it kind of kills two birds with one stone. So left equals max of whatever is left at the current position, and then answer of s right plus 1. Alright, I can get behind this. And then we just need to return length and initialize all of them to 0. Okay, let's run it. Let's see if our logic is correct. Okay, looking good. Nice! So this was actually the fastest solution. Okay, so those were the first 3 LeetCode problems. I definitely think it was really fun to do these. LeetCode is kind of just like a little puzzle that I take up. It makes the day go by, and they are pretty fun to do once you get into the rhythm of it. So yeah, I hope you enjoyed this video. Have a good rest of the holidays, and thank you for watching.